Assalamu alaikum and welcome to Mathcast with Faria Yusuf. And this video is for trigonometry, past papers questions, and it is part 2 of the past papers question. So now the question that I have chosen is from summer 2022, paper 1, variant 3, and it's question number 2 in the paper. So it says the diagram shows part of the curve with equation y equals p sine q theta plus r. P sine q theta plus r, where p and q and r are constants, and we have to state the value of p here. So if I look at the equation, it's y, which is equals to p sine of q theta plus r, and they are asking us for the value of p. So p, we know the coefficient of the sine theta, any trigonometric ratio, that has to be the stretch along the y-axis, in the y-axis with some stretch factor, and in this case the factor is p. So if this is the stretch factor p, then what I know here is I have the sine curve, and if I just look at the mid-axis of the sine curve, this is going to be the mid-axis of the sine curve here. So from the mid-axis, I can see that on both the sides, upwards, and then we should be moving downward. So from the mid-axis, the amplitude is 1, 2, and then 3. The amplitude is a 3 unit downward, and 1, 2, 3, 3 unit upward. So I can see here that the stretch in the y-axis with the factor p should be equal to 3 here. So this p value here should be equal to a 3. Part B, state the value of Q. So again, if I look at the curve equation which is given to us, now P value here we have said it's a 3, then it's sine of Q theta and a plus R. So Q now is actually the period for the sine theta, the rotations for the sine theta. So in this case, what I know is that the cycle, the period of this sine theta function here is going to be a 4 pi. This is how the cycle is getting completed. So if this is a 4 pi, then to get the period is a 4 pi. Then to get the q value, I should say that normal cycle for sine takes a 2 pi. Therefore, 2 pi should get divided by q, and we know q is the stretch in the x direction. Therefore, solving it, I can say that my q value here has to be a 1 by 2. So this is how I shall be getting the value of q here. And then finally, they are saying find the value of r also. State the value of r. So to state the value of r has to be the translation along the y-axis, and in this case I can see it should be the mid-axis which should be representing r. So mid-axis should be representing r here, or mid-axis, or we can say it's the translation along the y-axis, and I can see that this translation is a negative 2. Therefore, the r value then is going to be a negative 2 here. So this is how this question needs to be done. And in all, if I need to write the equation, I can simply say that this equation is going to be y, which is equals to p, which shall be a 3 sine of 1 by 2 theta, and then it should be a negative 2 here. The second question is taken from winter 2019, and it's paper 1 variant 1, question number 5 in the paper, and part 1. It says given that 4 tan of x plus 3 cos of x plus 1 over cos of x equals 0, show without using a calculator that sine of x equals negative 2 by 3. So they have given us 4 tan of x plus 3 cos of x, and then it's plus 1 over cos of x, and this then shall be equal to a 0. This whole equation should be equal to sine of x, which is equals to negative 2 by 3. So to start with, I should be using the identity, and we know the identity for tan of x is sine of x divided by cos of x. So using this identity, I can substitute for tan of x, and I can say it's 4 sine of x divided by cos of x plus 3 cos of x and a plus 1 by x, 1 by cos of x, which should be equal to 0. So if I take the LCM, I will be having 4 sine of x plus 3 cos square x and a plus 1, and this then shall get divided by cos of x, which should be equal to 0. So this cos of x can get multiplied with 0 and can get eliminated. Therefore, here I will be left only with 4 sine of x plus 3 cos square x plus 1, which should be equal to 0. So cos square x, again using the identity for cos square x, I know that cos square x shall be equal to a 1 minus sine square x. So doing that, I should be having here 4 sine of x plus 3 1 minus sine square x and a plus 1, which shall be equal to 0. So it's 4 sine of x plus 3 minus 3 sine square x plus 1, which is equals to 0. Simplifying the equation, this becomes 4 sine of x minus 3 sine square x and plus 4, which shall be equal to a 0 again. And solving it further, I can say that I should be having 3 sine square x. If I take the negative sign common, I should be having negative bracket 3 sine square x minus 4 sine of x and a negative 4, which then shall be equal to a 0. So our quadratic equation, the disguised quadratic equation, is 3 sine square x minus 4 sine of x and a negative 4, which should be equal to a 0. So for this equation, if I just solve the equation for m, let's say m is equals to sine of x and m square equals sine square x, I should say that my disguised quadratic equation is 3m square minus 4m and a minus 4, which is equal to a 0. So this is equals to a 0. Therefore, I can get the factors as 3m square minus 6m plus 2m negative 4, and this equals 0. I can take 3m common, and I'll be left here with m minus 2. From here, I can take 2 common, I'll be left here with m minus 2, which is equals to 0. So in all, I shall be having 3m plus 2 and m minus 2, which should be equal to 0. So m here should be equal to a negative 2 by 3, and m here then shall be equal to a 2. So as m was equal to sine of x, so sine of x is a negative 2 by 3 and sine of x is equals to 2. As this is greater than 1, therefore it's not possible. And the question was asking us to show that this can be solved without using a calculator, and we should be having the answer for sine of x, which equals negative 2 by 3. And here I do have the answer for sine of x, which is equals to negative 2 by 3, and I have shown the result here. So part 2 of the questions, hence showing all necessary working, solve the equation 4 tan 2x minus 20 plus 3 cos 2x minus 20 plus 1 over cos 2x minus 20. This is equals to a 0. So if I compare it with part 1, what I had in part 1 was 4 tan of x and a plus 3 cos of x and a plus 1 over cos of x, and this was equal to a 0. So the clear difference that I can see between the two equations is that this x here, this x here, this x here, and this x here, they have been substituted by 2x minus 20 in all the terms. Therefore, solving this equation in part 1, I got the answer as a sine of x, which was equal to a negative 2 by 3, which means just in place of sine of x, I can very easily substitute sine of 2x minus 20 degrees here. But before doing that, it's sine of 2x minus 20 degrees, which then shall be equal to a negative 2 by 3. But here again, I should be keeping in mind that they have given us the domain which is from 0 lesser or equal to x, which is lesser or equal to 180 degrees. So if this is 2x minus 20, I need to adjust this x to 2x minus 20. That means now I should be having these terms as equal to 2 times 0 lesser or equal to 2x. I'm just multiplying the whole domain by a 2 here. Therefore, I will be left here with 0 lesser or equal to 2x, which is lesser or equal to 360 here. And I can see that there is this negative 20 also. I need to balance it with the negative 20. Therefore, again, I will be adding the negative 20 here to the entire equation, so that this is 360 minus 20, giving us a 340 degrees. So this means that the domain for 2x minus 20 should be negative 20 lesser or equal to 2x minus 20 lesser or equal to 340 degrees here. Now let's look, this is the first step that we have done. Second step is to locate the quadrant. So sine being negative, I should be having this sign in the third and in the fourth quadrant. Sine is negative in the third quadrant, and then it's also negative in the fourth quadrant. So these are the two angles that I should be having, and I should know here that our given domain is from negative 20 degrees, and then it should be up till 340 degrees here. This is one thing that I should be keeping in mind. So let's start getting the basic angle. So the basic angle shall be equal to sine inverse 2 by 3, which is going to be the third step of solving trigonometric equations. Basic angle sine inverse 2 by 3 is coming out to be 41.8 degrees. Now, because the sine was a negative, we have located it in the third and the fourth quadrant. So in the third quadrant, this is going to be 41.8 degrees here, and in the fourth quadrant it should be a 41.8 degrees over here. So with that, if I solve the equation, then I can see that my general angle has to be 180 plus 41.8, and it should be a 360 minus a 41.8, which shall give us the answer as 2x minus 20, which then shall be equal to a 0.8 and a 1 and a 2 and 221.8 degrees. And here it should be a 318.2 degrees. So 221.8 degrees and 381.8 degrees, both of them, they are within the domain of negative 20 and 340 degrees. Both are valid here for 2x minus 20. Therefore, I can just find out the angle for x, and this angle of x then should be equal to 2x, which is equals to 221.8 plus 20, and also 318.2 degrees plus 20 degrees here. Or I can say this is 2x, which is equals to 241.8 degrees, and here I should say it's a 38.2 degrees, and dividing it by 2 to get the x values, I should say that my x values here are coming out to be 120.9 degrees, and then it should be 169.1 degrees here. So this is how this question should get solved for this question. Let's move to the next. So the next question is chosen from Winter 2022, Paper 1, Variant 3. And this question says that it's given that alpha is equals to cos inverse 8 by 17. So it's given alpha which equals cos inverse 8 by 17. And we have to find, without using the trigonometric functions on the calculator, the exact value of 1 over sine alpha plus 1 over tan alpha. So this means I need to have the value of sine alpha and tan alpha. So starting from the given equation for alpha, I can just say that it's cos of alpha, which is equals to 8 by 17. So cos of alpha being 8 by 17, I will be taking help from the right angle triangle in the first quadrant where my cos alpha is a positive. And if this is the right triangle that I should be having, then this is going to be the alpha value. We know that cos of alpha is equals to adjacent over hypotenuse. Therefore, my adjacent here is an 8, hypotenuse here is a 17. Therefore, perpendicular needs to be 17 square minus 8 square. So this answer here is going to be an under root 225, which then shall be equal to a 15. So I have the opposite also, and opposite here is going to be a 15. Adjacent here we have decided, as given in the question, it was an 8, and hypotenuse here was equal to a 17. So very easily I can say it's sine of alpha, which is equals to opposite over hypotenuse, and therefore this value then becomes 15 by 17, and tan of alpha shall be equal to opposite over adjacent, and opposite and adjacent, they are 15 by 8 here. So it's very much clear that they are saying without using the calculator we need to find 1 over sine alpha plus 1 over tan alpha. So we can just substitute the values for sine of alpha and tan of alpha. It's 15 by 17 plus 1 over 15 by 8. So I can solve this equation and I can say it's a 17 by 15 plus 8 by 15, or I can say it should be a 17 plus 8, which then shall be equal to a 25 by 15, and I can simplify and give the answer as a 5 by 3, or further I can say it's a 1 whole 2 by 3 here. So this is then going to be the answer for this question without using calculator. Next question is taken from February March 20, year 20, and it's paper 1 variant 2, and it's question number 11th in the paper. Part A, solve the equation 3 tan square x minus 5 tan of x minus 2, which is equals to 0, and we need to solve it for 0 degrees lesser or equal to x lesser or equal to 180 degrees here. So to solve the equation, again we know that this is the disguised equation where we can simply assume our m to be tan of x, and with that this equation can get reduced to 3m square minus 5m minus 2, which then shall be equal to a 0. So with this as 0, we can simply apply the formula, which is going to be negative b plus minus under root b square minus 4ac divided by 2a to get the tan x values. So b is a negative 5 plus minus under root negative 5 the whole square minus 4 times 3 times a negative 2, and this then should get divided by 2 times a positive 3 here. A value here is a positive 3, therefore solving it further I should get a plus 5 plus minus under root 25, minus into minus will be a plus 4 times 3 times 2, that gives me a 24 divided by 2 times 3, which is a 6. So here I can say it's a 5 plus minus under root 49 divided by 6, or further I can say it's a 5 plus minus 7 divided by 6 here. So I shall be getting two values of m. Therefore, in this case, it's the basic angle, or it's actually the x value here. So this x value here then shall be equal to tan inverse 2, or simply I can say that in this case, for tan inverse 2, this is going to be a 63.4 degrees. Now to get the basic angle here, it's a tan inverse 1 by 3. I've located it in the second quadrant where my tan is a negative. So the basic angle for tan inverse 1 by 3 shall be, the basic angle in the second quadrant shall be an 18.4. This angle here, this is an 18.4 degree. So the x value here is going to be 180 minus 18.4, which gives us the angle value of x as 161.6 degrees. So the solution for this x is going to be a 63.4 degrees and 161.6 degrees here. So this is how this part A for this question needs to get solved. I have solved part B. Find the set of values of k. They are asking for the set of values of k for which the equation, it's 3 tan square x minus 5 tan of x plus k, which shall be equal to a 0, and it has no solutions. So we can see that here we have a quadratic equation, 3 tan square x minus 5 tan of x plus k. It's a quadratic equation, and then they are saying that there should be no solution. That means we have to relate it to the first chapter of our P1 math, which was quadratics. So from quadratics, we know that when there is no solution, our discriminant value b square minus 4ac, it has to be less than 0. So this is how they have related trigonometry to quadratic equations, the discriminant formula, b square minus 4ac, it should be less than 0. So here applying b in this case, it's a negative 5 the whole square, minus 4 times a, which is a 3 in this case, and c, which is a k in this case, and this should be less than 0. Or here I can say it's a 25 minus 12k, which is less than 0. Or further, I can say it's a negative 12k, which is less than a negative 25. Solving for the negative sign, we know that we have to change the inequality. Therefore, this becomes a positive 12k, which should be greater than 25. Or I can say that there is the set of values of k, which should be greater than 25 by 12. So k here should be greater than 25 by 12. Part C says, for the equation 3 tan square x minus 5 tan of x plus k equals 0, state the value of k. We need to state the value of k for which there are three solutions in the interval 0 to 180 degrees, and we need to find these solutions also. So if we analyze the equation, it's a 3 tan square x minus 5 tan of x plus k, which is equals to 0. So if we analyze the equation, we should be finding out the three solutions within 0 to 180 degrees. So to get the three solutions, let's start substituting with our k, which is equals to 0. So if I equate my k as a 0, then I will be having here 3 tan square x minus 5 tan of x plus 0, which is equals to 0. Or here further I can say it's a 3 tan square x minus 5 tan of x, which shall be equal to 0 here. So this means if I take tan of x common, I will be left here with 3 tan of x minus 5, which is equals to 0. So here there are two values of tan of x. One is tan of x equals 0, and the other is 3 tan of x minus 5, which is equals to 0. So within the domain of 0 to 180 degrees, which is given in the question, we know that tan of x is 0, where our tan inverse is 0, and there should be two values. One is a 0 degree and the other has to be 180 degrees. So these are the two solutions where the tan of x that becomes a 0 value. Solving this equation, equating it to 0, I should be having another value for tan of x, which is a 5 by 3. And further, I can say it's x which is equals to tan inverse 5 by 3, and this should be in the first quadrant, being positive for tan value. So if this is a positive for tan value, then I should know that x which equals tan inverse 5 by 3, this is equal to, so this value then is equals to a 59 degrees. So the three values are going to be 0 degree, 180 degrees, and also a 59 degrees. Or rearranging them, I can say it's x which is equals to 0, 59 degrees, and then 180 degrees here, where our k was equal to a 0. So this is then going to be the solution to this question here. So this is the end of trigonometry. Hope you enjoyed the topic, and in the next video we'll be starting the new chapter. So best of luck to everyone.